Hello.
Hi, hello.
Yeah. Can you hear me?
Yes.
Okay. We'll discuss the paper that you have sent. Uh, Actually, it seems pretty easy on looking at it. It is easier than AMC 12 for sure.
Oh, okay.
So if you prepare AMC 10 and AMC 12 papers, if you do enough of those, I think this first round should be a pretty easy one.
Oh,
So we will discuss some of the problems, but what is your current level of prep? What have you done so far?
I mean, for last year, I prepared for AMC 12 a little bit, but it
Hmm.
wasn't expensive. So that one, I think I scored around 80 marks.
You can write AMC 12
Yeah, last
in
year,
Singapore.
yes, yes,
Okay. So you got around 80.
yes.
And in AMC 10, you have not written, right?
Oh, no, that was my only attempt.
Okay. So AMC 12, it's again 25 questions, right? Was the AMC 12 paper also 25 questions?
Yes, yes, it was.
And it has 150 marks, right?
Yes, I think so.
So that is the level that you need to increase. Like from 80, you need to get to 120. If you're getting to here, then you will be easily clearing this round. It is very easy actually, the paper that I saw.
Okay.
So subject wise, like in Olympiad prep, like there is obviously algebra, number theory, combinatorics, and geometry. What have you done in each? What is your situation in each of them?
Okay, so geometry, I'm doing the book you recommended me, The Beautiful Journey Through Olympiad Geometry.
Right. That is that will have way more stuff that you actually need, right?
Okay. Yeah, so I'm on like the fifth chapter of that. And then for AMC 12, I just solved past year papers. Like I didn't like specifically prep for anything.
Right. Turning to Olympiad geometry. So this is good, but make sure that whatever chapters you do, you try everything and understand everything here. It's a very good book, but like you need to go slow and make sure that you get everything. Okay.
Yes.
So are you understanding when you're doing this?
Yeah, I kind of get it. I can like, I do like most of the examples and the problems.
Right.
The problem,
Okay. Okay. So algebra, like you have not specifically studied it at all so far.
not really, no.
So technically the topics that are there in algebra that you need to work on, I will just list down some of them. So, so basically there are things like sequence and series,
Yes.
then polynomials. Third is theory of equations. Then there will be logarithms,
Yes.
logarithms. Then a little bit of inequalities, inequalities. Uh, there is some functional equations, and sometimes some advanced topics like recursive sequences and so on. Recursive sequences, telescoping series, not too many extra topics, but these are the major parts of your algebra.
Oh,
Okay. So what you need to do is practice problems on this. I can send some handouts and I can send some problems for you, but I remember you had also taken a Udemy course that I had made, right?
yeah. Yeah.
Which one had you taken?
It was the master class one, the one with it.
So Math Olympiad Masterclass has a lot of topics, but there are algebra topics there also.
Yes.
These chapters are there in that. If you just go through the relevant videos on those chapters.
Okay. Sure.
So don't forget to do that before your exam. If you just go through them and do all the examples in discussed in those videos, no,
Yeah.
that will already be at a higher level than this exam.
Okay.
Okay. Math Olympiad Masterclass, that course is at a much higher level than this exam. Okay.
Okay.
So you probably won't need everything there, but you need certain things there. Okay.
Okay.
Number theory. Do you know basic theorems and all?
Like little bit, not much. Number
Okay,
theory and combinatorics I haven't studied like at all, basically.
okay. But
Even if
algebra and geometry you have studied a little bit.
geometry I've done a bit, algebra like little bit also. Like I haven't like properly studied anything.
Okay. And what is your schedule like from now to the exam?
Like most of the days I can dedicate about 1 to 2 hours for like 5 days in a week. But like Tuesdays and Thursdays I'm really busy, like morning to night.
So
So
you have school going on right now? Do you have school going on?
yes, absolutely.
And when is the actual day of the exam? What is the date?
4th June.
4th June. So April, May you have. Okay. So 2 months should be plenty of time to cover all of this in a good way to clear this exam. Okay. So uh, that means 8 weeks you have. So we can devote like 2 weeks per subject if we need to,
Okay, sure.
right? So what we will focus on at the beginning right now is the easiest thing, which is algebra. Okay. So the next 2 weeks, I want you to focus on algebra and how do you prepare at home. One thing you can do is the Math Olympiad Masterclass videos on algebra,
Okay,
right? There are going to be there are 45 lectures. I'm guessing 10 of them will be algebra roughly.
okay,
Okay. You need to look at the topics, see which topics seem like algebra and do the videos there. Okay. That is one thing you can do. You have to do that in the next 2 weeks. Okay.
okay,
Like we have to make a planned strategy and that's how we make sure that we succeed in the exam, right? We cannot do random things. Okay. So we cannot do what we feel like is okay, let's do this. That cannot be the way you do it. Okay. So next 2 weeks is devoted to algebra and it is to make sure that we are at this level where AMC 12, AMC 10 problems on algebra you can easily handle. Okay. So that is the target. That is similar to this exam. So the reason I'm not saying this exam problems is because it's hard to find the papers only, I think.
I think past year papers I can find online. I
But
can.
there is no point in trying to find so many papers and all. AMC 10 and 12, all the papers are available easily, right? So just use those. Okay. So don't spend too much time trying to find past papers of it. But when I did a brief search, it was quite difficult to find the papers.
Oh, okay.
So like because there's no, it's not there on AOPS, it's not there on normal sites, it's on weird places.
Oh,
So don't worry about that. AMC 12 and 10. So I want you to do videos from this course for algebra, then AMC 10 and 12 algebra problems from the last say 10 years.
okay.
Last 10 years. So 2015 to 2024.
Okay.
Any problem that you see, go through all the papers. All of them are on AOPS website. You find any algebra problem, try to do it. That's what you spend your time doing. Okay. Any problem that you are stuck on, mark it so that we can discuss it in class and we will learn all the required theory by doing problems. Okay.
Okay, sure.
Like, I hope you have basic level familiarity with all these topics, right?
Yeah, a bit, kind of. I mean, sequences, polynomials,
Uh,
logarithms, inequalities. Yeah, functional equations I haven't done much. But I,
Fine. So that is only one topic and it's hard, it's uncommon in at this level. So these are slightly advanced topics, but these are the main things that will come. Okay.
okay,
So because you have that basic familiarity, you can immediately start solving problems. And when we get stuck somewhere, then we learn the required theory. Okay.
okay, sure.
So that is the plan. So we'll start with algebra, then we'll move on to geometry. Okay. Then
Okay,
we'll do number theory, and then lastly we'll do combinatorics. Okay.
okay, sure.
So 2 weeks, 2 weeks, 2 weeks, 2 weeks. That's the rough idea. Okay.
Okay.
And the number of classes and all that you need, we can adjust and schedule it accordingly. So I don't know the time difference right now. What is the time there?
Uh, it's 7:38, so 2.5 hours. Right.
Okay, okay. So fine. So what time are you comfortable with? Like, see, yeah, are you free sometime in the mornings and all?
Mornings, not really. because I have school. So unless it's on weekend, then sure.
When do you go to school in the morning?
8 o'clock.
8 o'clock in the morning. Okay. So that is like 2.5 hours ahead. So when do you come back from school?
I mean, it depends. Like it's different every day almost. So
Okay. Roughly?
like Mondays, Wednesdays, and yeah, Mondays and Wednesdays I can do from about 5 p.m. onwards.
Okay. 5 p.m. you're saying India time or your time?
I can.
Your time. So your time would be around 2:30 for me, right? Then 5 p.m. your time would be 2:30 p.m. for me, right?
Yes, yes.
So that works for me, okay. So all the classes we can schedule around 2:30 or 3 p.m., something like that.
Oh, sure.
So that will be 5 p.m. for you, and you can decide how many classes you need. It totally depends on how much work you are putting in. When you do more work, you'll have more issues, and then you'll need more classes. Okay.
Okay.
So let's right now discuss some of the problems, but you will get the general idea of how we plan to do it, right?
Yes.
So our sequence is this: algebra, geometry, number theory, combinatorics.
Okay.
Okay. And we'll give 2 weeks number theory, combinatorics, and we'll give 2 weeks for each topic. And for each thing, you can use the Udemy course for videos and theory.
Okay.
Whatever theory is there in that course is more than enough for your exam. Okay.
Okay. Sure.
That course that was made to keep in mind your national round exams. So this is much lower than that. National Olympiad types. It's at that level. Okay. So you should use that course extensively to watch the relevant theory. But problems, you need to do AMC 10, AMC 12 questions.
Okay. Sure.
And use the AOPS website to find the problems, right?
For the AMCs, like which range of problems should I target?
No, uh, right now, for the example, for algebra, because you don't have a lot of familiarity with it, you should target any question that you see is algebra.
Okay. Sure.
Don't discriminate and all. Right now, I don't think you are at that level to like decide for yourself. Okay. So if you had prepared a little more and all, no, if you had some more experience preparing for contest maths, then you could yourself have decided, okay, this is too easy, I don't want to do it, right? But right now, just to get that confidence and get that feeling that I can solve it, you need to solve whatever you see.
Okay.
Okay. AMC 10 problems are sometimes not so easy. Okay. 15 to 25, especially the questions at the end, right? You will find out when you do it. They're not so easy or anything. Okay. And similarly, AMC 12 also similarly. So both of these papers will have enough questions at the level of the SMO open round that you are trying to target,
Okay.
right? So that is the plan. Practice from here. Watch the relevant videos for theory from the Math Olympiad Masterclass course. Okay. Right now we'll start and we'll discuss some of the problems here. So did you do the first one?
I have not done that paper yet. It was just to send it to you.
Okay. So let's discuss. Tell me what you think about the first one. Open that paper up. Sk is 1 plus 2 plus 3 till k. For any positive integer k, you have to find S1 plus S2 till S20, right?
One.
Get that paper open and we can discuss some of the problems here.
Okay. Okay. Yeah. Got it.
So tell me what you would do here. What kind of a sequence does this look to you?
Like AP.
Right. So you should be able to find the sum of this AP, right? Or an expression for this, right?
Yes.
By the way, this is such a common expression that you should already know the answer. The answer is this: k into k plus 1 by 2.
Yes.
This is the
Okay.
sum of first n natural numbers, right?
Yes, yes.
So this can be obtained by using the AP formula. There is no issue in this. I hope you understand, right? You need to confirm whether you get this.
Yes, yes, I got it.
So now how do we sum it up, right? Because our job is not to find SK. Our job is to find S1 plus S2 till S20, right?
Yes.
This is like this, SK, and you have to do sum from K goes from 1 to 20, right?
Yes.
It's very easy. K goes from 1 to 20. Let's put the expression for that, K into K plus 1 over 2. So this becomes sum over K goes from 1 to 20. This is K square over 2 plus K over 2, right?
Yes.
Any summation, you can always split it into two separate summations. So we can say K is equal to 1 to 20 K square over 2 plus K is going from 1 to 20 K over 2, right?
Yes.
Constants can be taken out of summations. So we can say half of summation K goes from 1 to 20 K square. I have taken the half constant outside, right? Plus half of K goes from 1 to 20 K, right? Now notice, what is this? This is the sum of the first 20 squares, right?
Yeah, so it will be K, K plus 1, 2, K plus 1.
Right. And this is what? This is
K,
again
K.
sum of first and natural numbers. So K into K plus 1 over 2, right?
Yes.
But actually you are going up to 20, so you can just directly write the answer, right?
Yes.
Correct? It will be 20 into 21 by 2 here. And here also you can directly write the answer. So half into K, so 20. 20 plus 1, 21. 2 into 20 plus 1, 41 by 6, right? Plus half of 20 into 21 over 2, correct?
Yes.
So now notice that 3 cancels here, 2. This becomes a 7. And you have a 4 here. So this becomes a 5. So you have 35 into 41 here. And here you have a 5 plus 105, right? Correct?
Yes. Correct.
Just calculate this, you'll get the answer.
Okay, got it.
So this is super easy, right? There is nothing here, right? Is
Yes.
it clear?
Yes.
Let's look at the second one. Again, sum S over, this is the summation over R. R goes from 1 to 64. And the expression that they are giving us is R times 64 CR, right? I hope you know that symbol NCR.
Yes. Yes.
So now you have to find out log base 2 of S. So basically you have to find this sum and then take a log base 2 of it, right? Now, if you have studied a little bit of binomial theorem, this is one of the chapters that I missed writing out. In algebra, this is also one of the chapters, but usually it will be something that you'll see in combinatorics, binomial theorem and all. So have you seen binomial theorem before?
Yes. Yes.
So you know about all of this, right?
Yes.
Something like this will come, no, when you expand it. N, C, N, Y power N, right? So all of these terms come as coefficients of the binomial expansion, right?
Yes.
So all you need to understand is what can we do about this? You cannot do a direct summation right now because what will happen is it is varying in two places, right? This is how the series is going to look like to you, right?
Yeah.
So the problem is that two places things are changing. So you need to change it somehow or find a alternative version of the same thing, which is easier to add up. Okay.
Okay.
Right. So we will try to understand R into NCR. What is that? There is a very famous identity about it, but I'll just show you. So R into NCR is what? R into N factorial by N minus R factorial and R factorial, right? Correct?
Yes.
And R cancels here and this becomes R minus 1 factorial, right?
Yes.
Okay, so now you have N factorial by N minus R factorial and R minus 1 factorial, correct? Now think about it. The sum of the denominator terms is becoming n minus 1, right?
Yes.
It would be nice if the top part was n minus 1 factorial, right?
Yes.
Then we could have written it as n minus 1 CR minus 1, no?
Yes.
You understand? N minus 1 CR minus 1 would be n minus 1 factorial and this stuff only. N minus R factorial and R minus 1 factorial, right?
Yes, got it.
Right. So it would have been nice if there was n minus 1 factorial on top, but we have n factorial. So we can rewrite it as n into n minus 1 factorial, no?
Yes.
And now this whole denominator is going, this three terms are going to become what? N
Uh,
into n minus 1 CR minus 1, right?
yes.
So that is the identity. And this is a very famous identity. Anyone who has seen any of little bit of combinatorics also knows that you can transform your coefficients like this. R into NCR is equal to n into n minus 1 CR minus 1.
Oh,
Why is this useful for us? Here there were two places where the summation was changing. No variable was there, right?
now there's only one.
Now there is only one. N is a constant, right? So we can write it as summation. R goes from 1 to 64. R and NCR, N is 64. So we'll write it as 64 into 63 CR minus 1, right?
Yes.
Correct? I have just put N is equal to 64 in this identity, right? I hope you're understanding.
Yes.
Now this sum is super easy because we can take 64 outside common and this is a summation of R goes from 1 to 64 of 63 CR minus 1. If you think about it, that is what? That is 63C0 plus 63C1 and goes on till 63C63, right?
Yes.
This is what? Tell me.
I don't know how to calculate the sum of this.
So that means your binomial theorem you've not studied at all. That just tells me that. Or maybe it has been studied so long back that you've forgotten everything, right?
In touch.
Right. So this is a very obvious series summation. So you need to revise. The binomial theorem has now been added to the list of things you need to study. Okay. So in these 2 weeks in algebra, add binomial theorem to it. Okay. So this is x plus y power n. You know the expansion, right?
Yes.
Let's write some of the terms of this expansion. nc2 x power n minus 2 y square. This goes on till ncn y power n, right?
Oh, so this is like 2 to the power of n.
Yes. You put
Oh,
x is equal to y is equal to 1 in this.
okay.
As soon as you do that, you get 2 power n is equal to nc0 plus nc1 till ncn, right? This is a very famous identity, very simple, right? So this is clearly 2 power 63. No, all the terms are there, right? Nothing is missing, right? Correct?
Got it.
So this becomes 64 into 2 power 63. And 64 is actually 2 power 6, right? So
Yes.
this is 2 power 69 and I have to do log base 2 of s. So answer is 69.
Got it.
So again, simple transformation of the binomial theorem and then summation. It
Okay.
uses only basic concepts, nothing advanced was used, okay?
Yes.
It just needs familiarity with the chapters. It doesn't require too much. So that's why reading the theory or relevant theory from videos or whatever, you need to do that and start doing AMC 10 and AMC 12 problems. All of these concepts will be played out there. Okay.
Okay.
Okay. Question number 3. Find x, let x be the largest number in the interval 0 to 2 pi such that this x belongs to 0 to 2 pi and it is the largest number such that what is satisfied? Sine to the power 2024x
Minus.
minus cos to the power 2024x equals to 1, right? And we have to find out the GIF of this, the floor function of x, right? Do you know the meaning of floor function and ceiling function? Or greatest integer function, GIF? You know that, right? Okay, so what do you think we should do here? Actually, I want you to try it. I don't want to give you the solution so easily. So I want you to try 3, 4, and 5, okay?
Okay, sure.
Just try three, this one, the next one, and the next one. These three problems, you have around 10 minutes.
Okay, sure.
I'll be back in 5 minutes, okay?
Okay, sure.
Any progress here?
I got question 5. I'm trying 4 now. 3 I wasn't too sure.
Okay. We try it for 5 more minutes. We'll
Oh,
discuss.
okay. Wait, for question 3, like I think the answer is that x doesn't exist. Is that correct?
The answers are there, no? Three. Question 3, the answer is 4 apparently.
Oh,
So x does exist. It's just that we have to think of how to get it. So I can discuss it if you are not getting the idea. So,
question 3, could you discuss it?
right. So if you think about it, what we know is sin x values go from -1 to 1, right?
Yes.
Okay. And if you think about sin square x, what will be the values of sin square x?
0 to 1.
And the same goes for cos x also.
Yes.
So 0 to 1 is the range of values of cos square x, right?
Yes.
Now, if you think about it, this can be written as sin square x to the power 1012, right? Minus cos square x to the power 1012.
Yes.
Why am I doing that? I'm doing that because I know for sure that sin square x and cos square x are both positive,
Okay.
right?
Yes.
So what will happen now is I need to ensure that this thing minus this thing is 1, right?
Yep.
So the only way that can happen, because if you think about it, sin square x to the power 1012 is equal to 1 plus cos square x to the power 1012, right?
Yes.
Can sin square x to the power something be bigger than 1?
No.
No, right? See, even if sin square x was equal to 1, its values, when you raise it to power, it can never be more than 1, right? Do you understand what I'm saying?
So there's
You
no sin square x.
no, so try to think what I'm saying. If sin square x was equal to 1, in
Yeah.
that case, whenever you raise it to any power, it will always be equal to 1, right?
Yes.
But on the other side, this is looking like 1 plus something, right?
Yes.
So the equation will not be satisfied unless this something is 0 and this is 1, right?
Oh, okay. Yes.
See, the only way it can be satisfied is if this is equal to 1 and this is 0, right?
Yes. Yes.
What if sin square x was actually less than 1? If sin square x was actually less than 1, which is also possible here, right?
Yes.
In that case, when you raise it to a power 1012, it will always be less than 1, right?
Yes. So it won't be possible.
That won't be possible because this side is always greater than or equal to 1, right?
Yes.
So basically, no solution in that case, right?
Yes.
The only solution happens when sin square x is 1 and cos square x is 0, right?
Yes.
Now, that is a very easy situation to talk about, right? Sin square x is 1, cos square x is 0, right?
Yeah.
Sin square x will be 1 if sin x is 1 or minus 1, right?
Yes.
Correct? That can happen at pi by 2, 3 pi by 2, 5. Okay, pi by 2, 3 pi by 2. Those are the two values between 0 and 2 pi, right? How is that obvious to me? Because I know the graph of sin x. Okay. So you can figure it out by drawing the graph of sin x, right? I hope you're understanding what I'm saying.
Yeah.
See, this is the sin x graph, 0, this is 2 pi. Notice that 1 happens here, minus 1 happens here, right?
So it can be pi by 2 or 3 pi.
Pi by 2 or 3 pi by 2, right?
Yes.
So those are the two values that this happens. And at pi by 2, cos x is what? 0, right?
Yes.
At 3 pi by 2, also cos x is 0, right?
Yes.
So actually both of the conditions are solved at these 2 points, right? Correct?
Yes. Yes.
So the two answers are pi by 2 and 3 pi by 2. And the answer that we want is the maximum answer. So 3 pi by 2.
Yep.
3 pi by 2, now calculate. You will realize that it is 9.42 by 2. So that is roughly 4.7 something. GIF of that is 4,
Okay.
right?
Yes.
Are you understanding what we have done?
Yes. Yes.
See, there is no other way to solve an equation like this because you can't do anything with 2024 powers and all, right?
Yes.
All you can really think about are the range of values that sine and cos can take. And this is a very common argument. The reason you are not able to do it is because you have never seen it before.
Yeah, I got to the step where it's 1 plus cos square x, but then I didn't think it could be
Uh,
like, I was like, how would it be greater than 1? So it's not possible.
right,
But
but it could be 1 and 0, no?
yeah, yeah.
So these are common tricks that with a little bit of practice or familiarity with them is what will help you solve it. Okay. So that's
Okay.
why you need to see many questions because
Okay.
this is a very frequent question. Okay.
Okay.
Like many variations of this can be given, but right now we will move on. Let's look at the other problem. Fourth one, did you do?
Fourth one, I got infinitely many numbers. Is that correct? Because I squared both sides and then it was canceling out.
So, no. So, see, the answers are already available. You don't know
Oh,
the answers are there.
no.
Okay, so you have not downloaded the answers. I have downloaded the answers. It is there from some site. I got it.
Okay.
That is not the correct answer. So let's think about what you do in such questions.
Okay.
Usually, what you said, squaring, usually that is a bad strategy. We'll discuss why. So
Okay.
find the number of real x such that satisfies this equation. Mod of x minus 2 plus mod of x minus 3 is equal to mod of 2x minus 5. Okay. The
Yes.
number of real x that satisfies this equation. I hope you know the meaning of mod of x.
Yes. Yes.
How can we write it? What is the definition of mod of x? What is it?
It's like x if x is greater or equal to 0, and then minus
Hmm.
x if x is less than 0.
Right. So the standard way to solve situations where there are modular signs is to take cases and remove the mods one by one. Okay.
Okay.
So you can remove it at once also if you want, but you need to put all the mods on a number line and take cases where x can be something, then what will be the sign of this mod and so on.
But I
So
thought squaring automatically gets rid of it. So why can't
it
we do?
automatically just ruins everything because squaring will introduce new solutions which are not solutions of the original equation. It produces
Oh,
extra roots.
okay.
If you do squaring, you have to be again at the end, you have to be careful about whether you have made roots or you have gotten new roots that are not roots of the original equation.
Okay.
For example, if x is equal to root of 4,
Okay.
this the meaning of this is x is equal to 2, okay? Because whenever you write root of 4, that means positive root only.
Yes. Yes.
But if you square it, you will get another root minus 2.
Yes. Okay.
If you say the answer of this is plus minus root 2, it's not wrong.
Okay.
Squaring is not something that you usually do. It is done as a last resort if there's nothing else left.
Okay.
So don't do squaring. You have to do cases. And this method that we will see here is given a name also. It is pretty common. It's called method of intervals or wavy curve method.
Okay.
What we will do is take portions of the number line and realize which mod is going to have what sign. Okay.
Okay.
So obviously we know that this mod will change its sign at 2, right?
Yes.
This mod will change its sign at 3,
3.
and this mod will change its sign at 2.5.
Yes.
Correct, no?
Yes.
So let's put all these three numbers on the number line. Obviously, with three numbers, the entire number line has been divided into 4 parts, right?
Yes.
We will do all those 4 cases separately, okay?
Okay.
So what we'll do is case 1. Let's say we are doing this case, okay? X
Okay.
is greater than 3, correct?
Yes.
In that case, all of the mods will have positive sign, no?
Yes.
You
Yes.
understand?
Yes.
So in that case, what will the inequality look like? X minus 2 plus x minus 3 is equal to 2x minus 5, right?
Yes.
So see that it is 2x minus 5 is equal to 2x minus 5, right?
Yes.
Wait, something is going wrong because then the question is wrong. Oh, okay. If there are infinitely many numbers, you have to enter 99999, right?
Yes.
So automatically you are getting 2x minus 5 is equal to 2x minus 5, right?
Yes.
So automatically it is satisfied for all numbers above this, right?
Yes.
So the answer will be 99999
Okay.
because already we get infinite no here.
Yes.
However, I just want to show you how you do it. So see, we took this case, all the mods were removed and we put positive signs on everything, right?
Yes.
And we got that everything, it's an identity, right? LHS is always RHS, right?
Yes. Yes.
Let's look at this case, right? When
Okay.
x is between 2.5 to 3, right?
Yes.
So what happens? This is going to be positive, no?
Yes.
But this is going to be negative, no? It's less than 3.
Yeah.
So you'll get a minus of x minus 3. So minus of x minus 3, correct?
Okay. Yeah.
And this is going to be what? Positive.
Yes.
So 2x minus 5, right? So
Yes.
notice what is happening here. X and x get cancelled and you're getting 1 is equal to 2x minus 5, right?
Yes.
So you're getting x is equal to 3, right?
Yes. Yes.
Now notice that our condition was this. So this does not satisfy, that condition.
Oh, okay. Yeah.
You realize that this
Yes.
answer will be rejected right now
Okay. Yeah.
because
Got
it
it.
doesn't satisfy the condition from where we got this equation, right?
Yes.
We had already taken x greater than equal to 3. All of that was fitting, right?
Yes.
Similarly, between here to here, basically from 2 less than equal to x less than 2.5, the equations will start looking like x minus 2 minus x plus 3 is minus 2x plus 5, right?
Yes.
Notice what is happening. 1 is equal to minus 2x plus 5. So this becomes a 2x is equal to 4. So x is equal to 2, which does satisfy the condition, right?
Yes.
The solution that we are getting in this range, 2 is a solution, right?
Okay. Yes.
And then when you do the last interval, which is this region, which is all will be negative, right?
Yes.
So it will be like this, minus 2x plus 5. Notice that this is an identity again, right?
Yeah. So it's
So
infinite.
everything less than 2 equal to 2 is a solution. Everything greater than 3 equal to 3 is a solution,
Okay.
right?
Yes.
And that is the standard way to handle mods. Always you have to think of the number line, think of cases where which part will be positive, which part will be negative, right?
Yes.
And then break down the cases, solve the relevant cases, and check whether the solutions that you're getting are satisfying the condition of that case, right?
Okay. Yeah.
At the end, we got 4 cases, and we combine all the solutions. This is our final answer, right?
Yes.
Are you understanding?
Yes.
What
Yes.
answer did you get for fifth one?
Fifth one I got 3. Is that correct?
Right, so that is correct.
Okay.
How did you do that?
I just brought it over to one side and then I made it into a quadratic, factorized it.
Okay, fine. Sixth one, uh, find the smallest positive integer c greater than 2024, smallest c greater than 2024, such that the sets A is equal to 2x square plus 2x plus c, where x belongs to integer, x belongs to z. Z stands for integers.
Yes.
And B, the second set is B is equal to x square plus 2024 x plus 2, where x belongs to integers again, are disjoint.
Okay.
Are disjoint means they have no intersection, right?
Yes.
No common elements.
Yes.
smallest C which is bigger than 2024 such that these two sets are disjoint. Okay, so A is the set of values that come out of this, right?
Yes.
When X is an integer, and B is the set of values that come out of this when X is an integer, right?
Yes.
Okay, so we know C is greater than equal to 2020, greater than 2024, so it will be greater than equal to 2025.
Yes.
Okay, so one way to think about it would be to figure out the minimum or maximum values of these expressions, right?
Okay.
Right, then only you'll get a sense, no? How can we make it disjoint, right?
Yes. Okay.
So, uh, let's think about it. 2x squared plus 2x
Plus C.
plus c. So c, what should I write? Okay, so let's write it as c only for now. This expression, we can complete the square if we want. We can say 2 common.
But we can differentiate also, right? For minimum. Like,
I didn't know you know calculus. That we can do, obviously.
yeah.
So if you know calculus, then you can do f dash x 4x plus 2 equals 0 and x is equal to minus half, right?
Yes. Yes.
And f double dash x, if you check, f double dash x is 4, so this is a minima, right?
Yes.
So
Yes.
this is a minima, so when you put minus half here, you'll get 2 into 1 by 4 plus 2 into minus half plus c, right? So this is half minus 1 plus c, so c minus half, right?
Yes.
So we know that the minimum value of A is going to be greater than equal to C minus half, right?
Yes.
Okay, let's find the values of this expression. So this is going to be 2x plus 2024 is equal to 0. X is equal to minus 1012, right?
Yes.
So the minimum value is going to be very low here, right?
Yes.
Because obviously, you can think of it as completing the squares also. Here you need x square plus 2024x plus 1012 square plus 2 minus 1012 square, right?
Yes.
This becomes x plus 1012 whole square plus 2 minus 1012 square.
Yes.
So this part can be 0 at x is equal to minus 1012, right?
Yes.
And then the value of b set will become this, right?
Okay. Yeah.
1 minus 1012 square plus 2, right?
Yes.
And for any other x above it, it will start taking higher values, right?
Yeah. Yeah.
So, okay, fine. And we know A values will be higher than this, C minus half. So, smallest C greater than this such that the sets are disjoint. Okay, so 1 second, let me just draw a rough graph. This is at minus half is the minimum of this one, and for this one, it's at minus 1012. Okay.
Yes.
So if you think of the rough graph of it, minus half is somewhere here, and C minus half. So the graph looks like this for this parabola. This is the A parabola. This
Oh,
value is C minus half, right?
yes.
This is x is equal to minus half, correct?
Yes. Yes.
The other parabola is like this, but it is at much farther away, right? It is here.
Yes.
It is at x is equal to minus 1012.
Yeah.
X is equal to minus 1012. Uh, and the value is also much lower, minus 1012 square plus 2.
Yes.
We need to make sure that these are disjoint sets. That means there cannot be any intersection here, right?
Okay.
No intersection.
Won't there always be an intersection?
No, not if this is growing faster than this or something like that, right?
Oh, okay.
Like it is
Yeah, like,
possible that there won't be an intersection if this is growing fast enough, right? So basically, what I want to do is I want to solve these two and see the condition for no roots, right? Do you
wait, but
understand?
even if it's going fast enough, won't it always intersect at some point? Because
No, it won't. What I'm
it keeps,
saying is, see, it
yeah,
is possible that this grows like this and this grows like faster than, like it has to approach it also. No, it is very far away.
yeah, yeah. Okay,
So it is possible that by the time it comes near here, it is much higher.
okay,
Do you
okay.
understand what I'm saying?
Yeah, yeah.
It is totally possible that they don't intersect,
Okay,
but it is difficult to decide that from the graph, obviously.
okay.
We need an algebraic way to decide that. And now, in order to, we got the hint that we don't need to prevent intersection, right?
Yes.
The way to do it would be to equate the two and say that no integer roots or
Solution.
no real
Yeah,
roots, right?
yeah,
So for x belonging to integers, right?
yeah.
We need to ensure that x belonging to integer actually, right? For x belonging to integer, there should be no intersection because both the definitions had x belonging to integer, right?
Yes, yes,
So let's say make it a quadratic x squared minus 2022x plus c minus 2 equals 0, right? See, this was much easier. We should have started with this.
okay.
Do you realize what I'm doing now? I'm saying that let's equate them, and now I'll
Yeah.
say that no roots, right?
Oh, yeah, yeah.
So for this, discriminant should be less than 0, right?
Yes.
2022 square minus 4 into c minus 2
Less
is
than.
less than 0, right?
Yes.
Okay. And basically that will become 2022 square by 4 is less than c minus 2. So c is greater than 2 plus 2022 square by 4, right?
Yes.
But still, that's a very big value. 1011 square it is 2 plus, right?
Yes.
I doubt that that will be the answer.
Yeah, I don't.
Uh, 1 second. Smallest positive integer. Is 2025 going to give a solution? Let's just check the next integer. Okay.
Okay.
I will not do it with general C. Let's check 2025. Okay.
Okay.
So we're getting 2023 here, right?
Yes.
2023 and whether this has real roots or not, right?
Yes.
So we can say actually we can't use this condition because we have to check for integer roots, not real roots.
Yeah.
Do you understand what I'm saying?
Yes.
If it was a real roots question, the answer is this, but that is not what the question is.
Okay.
So here, let's see if there is integer roots for this, right? So the
Okay.
way to do it is just realize that integer roots will happen only if the discriminant is a perfect square, right?
Okay. How does that?
You don't know the condition for rational roots.
Not wait.
If there is a quadratic like this, ax square plus
Yeah.
bx plus c equals 0, a,
Yeah.
b, c are rational numbers.
Okay.
Then what is the condition that the roots are rational?
Oh, I'm not too sure.
The roots will be rational if only the discriminant is a perfect square, no? How will this number become rational?
Oh, yeah, yeah. Okay.
The discriminant has to be a perfect square,
Perfect.
right?
Yes, yes.
Otherwise, it will be irrational.
Yeah, yeah.
Obviously, these are integer values. These are obviously rational numbers.
Yes.
If
Yes.
I want my root also to be a rational number, x is an integer, right?
Yes.
Integers are all rationals, right?
Yes.
So I can use the condition that discriminant should be perfect square, right?
Yes. Okay.
And then just check whether it's happening or not, right?
Okay.
2022 square minus 4 into 2023, right?
Yeah.
So this is comparatively easier to figure out whether it is a perfect square or not, right?
Okay.
Is it a perfect square? We are getting 8092 here.
Okay.
Okay, that is not a nice way to do it. 1 second. We can take 4 common here. 4 common 1011 square minus 4 common 2023, right? So
Yes.
4 common 1011 square minus 2023.
Yes.
Is it a perfect square or not? So we can say that this is 1011 square minus 2 into 1011 minus 1, right?
Yes.
2022 minus 1, right?
Yes.
It would have been a perfect square if it was a plus 1,
+1. Yeah, +1.
but now it is not. Do
So
you
we can,
understand?
so we can use a different number instead. No?
No, we don't
Instead.
have to. We see that this is not a perfect square
Yeah.
because it is 2 less than the perfect square, right?
Yes.
If it was a plus 1, it is a perfect square inside, right?
Yes.
But it is minus 1, so it's 2 less, right?
Yeah.
And 4 was a perfect square, so that was not a problem.
Yeah.
I have basically figured out that this is not a perfect square.
Yes. Okay.
That means this root cannot be irrational, right?
Yes.
So
Cannot be.
even at cannot be rational.
Yes.
So then it cannot be integers.
Yes.
So even for the number 2025, we are not getting integer roots, right?
Yeah.
So
So
that
we
means
can.
that there is no intersection. This is the smallest number after 2024, right?
Okay. Yeah. So now
If
do
we
we
had
try
to,
2027 like
no, we
that?
don't need to. We have already found the next number. The question was saying find the smallest positive integer bigger
Oh,
than
that. Yes.
2024
Yes. Got it. Got it.
such that they are disjoint.
Yes.
We already checked the next number, 2025, right?
And it's disjoint.
That's it. That's the smallest
Oh.
number then, right?
Oh, okay. Got it.
Okay. You need to try the remaining questions and we can discuss that. But remember what we have discussed, how you need to prepare. Okay.
Yeah. Okay.
Doing
So
a mixed selection of problems randomly won't help. You need to focus on algebra for 2 weeks. Okay.
okay, sure. So how many hours do I need to spend daily, like recommended?
As much as you can. There's
Oh,
no upper limit to it. As
okay.
much as you can find.
What's a good lower limit to
Greater
start with?
than 2 hours
Okay.
at least. Because you
Okay.
have only 2 months. Every day
Yeah.
you need to work at least 2 hours.
Okay.
Okay. But
Okay.
just make sure you work according to a plan. Next 2 weeks is algebra. Focus on that. Use AMC 10 and 12 papers.
Okay,
Okay.
sure. So if I have
Then
any question, could I text you or we
we will
go through?
discuss it in class because I have
Okay.
many classes. No, I will not be able
Yeah.
to respond with a solution
Yeah.
or
Yeah.
anything.
Got it. Got it.
We'll discuss whatever doubts you have in class.
Okay, sure.
Okay. Fine.
Yep.
That's all for now then.
Okay. Thank you so much.
Bye.
Okay. Bye-bye.